And welcome back. Okay, so in the previous video, we recapped the information about ionic bonding that you covered at IGCSE. This video, we're going to develop that and introduce a couple of new key points, all based around the strength of the ionic bonds. So hopefully, by the end of this video, should be able to state the different factors that affect the strength of an ionic bond, should be able to compare the sizes of ions based on how many protons and electrons they have, and be able to define isoelectronic ions and determine the relative size of their ionic radii. Okay, so first of all, factors affecting the strength of an ionic bond. There are two that you really need to know about. Okay, so the first one is the charge of the ions. As we covered in the previous video, an ionic bond is the electrostatic attraction between a positive ion and a negative ion. So the charge on the ion, the magnitude of the charge, contributes to the strength of the ionic bond. The bigger the number of the charge, the stronger the bond, the more attracted the negative and positive ions to each other. So basically, the force of attraction depends on the product of the charges of the ions involved. If you multiply the numbers together, the higher the answer, the stronger the bond. So for instance, if we had magnesium oxide compared to sodium chloride. Now with sodium chloride, Na has a 1 plus charge, Cl has a 1 minus charge. You multiply these together, 1 times 1 is just 1. With magnesium oxide, magnesium has a 2 plus charge, oxygen has a 2 minus. You would multiply them together, okay, to get 4, minus 4. Therefore, solely based on this information, the ionic bond is 4 times as strong for magnesium oxide than it is for sodium chloride. It's not quite so simple as that. Another factor is the radii of the ions. And basically, the closer the ions are together, the stronger the attraction. Therefore, the force of attraction varies inversely with the sum of the ionic radii. So you have the ionic radii for the cation, the ionic radii for the anion. You add them together to get the sum of the ionic radii within that ionic bond. And the smaller that distance, the greater the force of attraction. So these are the major two factors you need to be thinking about. A third factor is also the arrangement of ions. You can get several different structures, but you're rarely asked about this in your AS level. So it's these two factors which you really need to know and be able to use in answers. Now, unfortunately, I'm not just going to go through this in this video. The title may be to do with the strength of the ionic bond, but I want to go through one of these factors in a bit more detail. And that factor is the ionic radii. Now there is a reason for this. There are different styles of questions which are asked about ionic radii. It can be linked to the strength of the ionic bond, but there are other questions. So, factors affecting the ionic radii. One of them is the amount of electron-containing shells. Now obviously, the more shells there are, the bigger the ion. It's very simple. More electrons, further and further from the nucleus, overall the ionic radii gets bigger. Therefore, as you go down a group, the ionic radii increases because you're adding more shells. That one's reasonably straightforward. The second one is the nuclear charge. Now we've already looked at how in an atom, or in this case an ion, it's held together by the attraction between the nucleus, which is positively charged overall, and the electrons, which are obviously negatively charged. Now, the bigger the nuclear charge, the more pull there is on those electrons. I like to think of it like someone fishing. The fisherman is the nucleus, the fish is the electron. Now, the nucleus, or the fisherman, has caught hold of the fish and is pulling it towards him. Now, the more strength he has, or the higher the nuclear charge, the closer he can bring the fish. So as the nuclear charge increases, the electrons do get closer to the nucleus. So this is a factor you need to consider. So there's a reason you need to be thinking about these factors, and there is a style of question which normally looks a little bit like this. You are quite often given a row of ions just like this. Now hopefully you can realise that you're starting in group 5 of period 2, and you're just going across nitrogen, oxygen, fluorine, missing out neon because it doesn't form ions, then going on to period 3, sodium, magnesium, aluminium. And the question will be, put them in order of their size. Okay, so based on what we've already looked at, you may be thinking, okay, sodium, magnesium, aluminium, those atoms are all in period 3. They have one more shell than the previous 3 elements. Therefore, they're going to be bigger. And unfortunately, if you follow with that line of thought, you have fallen into the trap. So let's have a little bit of a close look at these ions. And just list how many protons and electrons they have. So nitrogen has 7 protons. Now a nitrogen atom has 7 electrons, but this is an ion, it's a 3- ion. It has gained 3 additional electrons. Therefore it has 10 electrons. Oxygen has 8 protons. It's an ion, it has gained 2 electrons, so it also has 10. Fluorine, 9 protons, but it's F-, so it's gained an electron, 10 electrons. I hope you're spotting a trend. Yes, sodium has 11 protons. Because it's positive, it has lost one of its electrons. Magnesium also has 10 electrons, as does aluminium. So these ions are what we call, so isoelectronic means they are ions of different elements that contain the same number of electrons. So iso is to do with balance, being the same. Electronic is to do with electrons in this case. Now this is a key word which can be used in questions or can be required in answers. So make sure you add this one to your glossary. Now let's go back to our original question. How do you put these in order of their size? So now we need to think about the different factors contributing to the ionic radii. Now, amount of shells, they all contain the same number of electrons. Hence, those electrons will be in the same shells. So the amount of shells will be the same. Now the second factor is the nuclear charge. Now obviously, the amount of protons is increasing. Now the more protons there are, the greater the pull on those electrons. So aluminium will actually have the smallest ion, and nitrogen will have the biggest. So when you're confronted with isoelectronic ions, which is quite a common question, either in the multiple choice or in a 1 or 2 mark longer answer question, you need to be thinking, you need to try and recognize that they will have the same number of electrons, and therefore the one with the greater number of protons will have the smallest ionic radii. Okay, so hopefully you'll be able to state the 2 factors that affect the strength of an ionic bond. You'll be able to compare the size of ions based on the number of electrons and protons they contain. And finally, you should be able to say what isoelectronic ions are, and hopefully you can compare the relative sizes of their ions. If you have any questions, make sure you write them down, and I'll see you in class.